Good evening, everybody. On the behalf of JC Bose University of Science and Technology, I welcome our today's speaker, Shri Hridesh Kalra ji. Hridesh Kalra ji is 1992 batch pass out from YMCA Institute of Engineering. He is having more than 28-year experience in stainless steel industry and welding in various multinational companies. After this vast experience, Sir started his own company in May 2015 and he is technical director in All India Stainless Tube Limited, Ambala. I welcome Sir for today's technical talk. Sir, please.
Thank you, Dr. Nikhil, for giving me the opportunity to speak on. Actually, the presentation is on the corrosion topic. The topic is why I chosen this. This very close to my heart, and I'm working in day and day out since last many years on the mitigation of corrosion with the various companies. So it is very important to make the people aware what the corrosion and what is its impact on the industry. So 1 minute. Sir, how to go to the next slide? Objective is to help engineers to understand the impact of corrosion so that they can solve the existing corrosion problems and prevent future ones, and to understand the methodology for material selection. So I will be covering the very brief topic of it. It can be the series of the lecture along with the corrosion, but I will be giving you the very brief introduction, and if another opportunity given, then I will connect those topics with this. So it's a corrosion. Actually, corrosion is having huge impact, which is often overlooked. India is spending huge amount of money on the corrosion mitigation, or is a corrosion cost is very huge for India. In the year 2011 and 12, one study was conducted by NBS CBL USA-based company. So they have estimated cost. They concluded the estimated cost for the corrosion for India is around 2.4% of nation's GDP, which comes to around $2.6 billion, and the estimated cost which can be avoidable is around $10 billion, and the indirect cost for the corrosion estimated is 39 or 40 billion dollars. So it's a huge cost for India for corrosion. And if you see the coastal line around 7,000 kilometers from Mumbai to Calcutta, it's a 7,000 kilometer estimated. This is highly corrosive, and the corrosion rate is around 0.25 millimeter per annum. And we are spending huge amount of money on the infrastructure, on the facilities and all those things. So just keeping aware of the things, what is the corrosion, and how next topic can be how to mitigate and what the action should be taken to mitigate the corrosion. Next slide is that on corrosion. What is corrosion? Degradation of the material by chemical reaction with its environment, as everybody is aware of it. So this is corrosion. 1 minute, sir. And stainless steel, it's a stainless steel. Stainless is not always stainless. So the passive layer on the stainless steel consists mainly of chromium and iron oxide, and form it spontaneously in environment containing enough oxidants. It forms spontaneously in environment containing enough oxidant. If the metal surface is exposed to mechanical damage, small scratch is given on the stainless surface, it comes back immediately. The passive layer comes back immediately, it becomes stainless. And if the heavy scratches are there, if it is exposed to heavy scratches or dents, then it will not, the original surface, passive layer will not come back to its original surface. So it happens a corrosion. So corrosion can be of many form. And if you see this 4307 is 304 grade, and this is 316 grade. It's fixed on this carbon steel, so it can be also be the corrosion. So I'll just show you how many types of corrosion are there. The corrosion forms of stainless steel is uniform corrosion, pitting corrosion, crevice, stress corrosion, then fatigue corrosion, then galvanic corrosion, intergranular corrosion, and atmospheric corrosion. And different media and service condition can cause a different type of corrosion attacks. It may vary in nature and appearance. Uniform corrosion. Uniform corrosion occurs uniformly over the entire surface, exposed surface, or over large area. And most cases of uniform corrosion occurs in strong acid or in hot alkaline solution. And it can be predictable also. If it's a constant rate and constant conditions are there, then it can be predictable that in how many days this corrosion can happen, or this material will live. And this water, there are many kind of waters. It's a tap water, it's a swimming pool, and it's a sea water. So different type of water and variable composition within the limits. Corrosivity associated mainly with chloride, oxidants, pH value, biological activities, and temperature. So this chloride content in the tap water is around 250 ppm, less than 250 ppm. But salty taste, more than 250. Brackish water which mix with the sea, it's 3000 ppm, and sea water is 20,000 to 30,000, depends on the area. Which area, it's a different sea having different ppm. Like if you go to the Kolkata side, it's a more ppm. If you go to Bombay side, it's less ppm. So it's very area to area also. But this how 20,000 to 30,000 ppm is a sea water chloride content in this. And so it's another form of corrosion. It's pitting corrosion. It's chloride ion causes a local breakdown of the passive film. Passive film is very thin layer on the stainless steel surface. It's a very thin layer, and it's you can say 1/100th of the one postcard. That thin, 1/100th of the one postcard. That thin is a passive layer on the stainless steel. It prevents the surface from becoming the corroded. So chloride causes a local breakdown of the passive film. Pitting occurs in the acidic or near neutral solution in the presence of chloride halide. The resistance of the stainless steel increases with the increasing amount of chromium, moly, or nickel. A chromium is, and moly and nickel is a element in the stainless steel. It's a different kind of stainless steel, which I will be covering in the future in case if I get the chance. The resistance increases with the increasing pH value greater than 11. This is pitting resistant equivalent number. Pitting resistance equivalent number is a number which can be calculated in any kind of stainless steel like 304, 316, or maybe higher grade material. So the PRE, the higher the pitting resistance equivalent, the higher the corrosion resistant property in the particular stainless steel. If I put 304 in the seawater application, it will be corroding very easily, 304 or 316. But if I put 2507 43 PRE number, it can withstand for some time as well. It depends on the temperature as well as the chloride content also. So the more higher PRE number, the more pitting resistant equivalent number, the more corrosion resistant property of the stainless steel. Crevice is the example of the flanges, or maybe The other area, pipe, this flanges, fittings. So where it's a shielded area, you can say, occur in the crevice, other shielding area in the acidic or near neutral surface in the presence of chlorides. The resistance of stainless steel increases with the increasing amount of chromium, moly, or nickel. Again, the same thing, and when you increase the chromium, moly, or nickel, then it increases the corrosion resistant properties as well. So this crevice also occurs. Factor affecting crevice risk of affecting the risk of corrosion, pitting and crevice, the increased risk by chloride or elevated temperature, oxidants, microorganisms, living waters, design, crevices, stagnant solutions, welding oxides, coarse surface. These are the factors affecting the poor welding or the drain pipe you see. You maybe oftenly you see this kind of corrosion at the various places, maybe in the home or offices or somewhere. So these are kind of corrosion you can see. This is a stress corrosion cracking. Stress corrosion cracking occurs due to the elevated temperature and solution containing chlorides, hot alkaline solution, swimming pool atmosphere, that's environment. The combined effect of tensile stress and corrosive environment. It's a caused because of the tensile stress and corrosive environment, but at the elevated temperature as well. This occur in the swimming pool when where the where the load bearing where it's collapsing the concrete roofs due to the stainless steel in the safety critical load bearing application in the environment created by indoor swimming pool, anchored roof surface like this. This is a stress corrosion cracking. So corrosion fatigue, it is well known that material that is subject to a cyclic load can fail at a load far below the ultimate tensile stress of the material. If the material is simultaneously exposed to a corrosive environment, then failure may take place even at a lower load and after shorter times. So it's caused by the combined effect of cyclic load and corrosive environment, can be caused by environments which are harmless with respect to other form of corrosion, may occur at room temperature. It's another form of stainless steel duplex, has a good corrosion fatigue resistance properties. So it's again another form of intergranular corrosion. It can occur if the steel has been stabilized, like if it is heat treated between the temperature of 500 to 900 degrees C. And if the stainless steel might occur as a consequence of the precipitation of chromium carbide or intermetallic phases. This is the form of where you can see this grain boundaries. It's corrosion occurs here at the grain boundaries. So it's low carbon steel or steel with titanium and niobium show the high resistance, rarely a problem with the modern stainless steel. The galvanic corrosion were two different form of 1 minute, sorry sir. One person was waiting there, so galvanic corrosion occurs where the two dissimilar metal are connected electrically and in contact with the conductive liquid. So this is galvanic corrosion. How this corrosion occurs? This is a corrosion, atmospheric corrosion, influenced by humidity, temperature, atmosphere, pollution, and salt. All these corrosion are can be mitigated, or it can be removed easily, or by the selection of the right material at the right place. It's a 316 railing beside the beach. On the beach also having discoloration. So discoloration will become a rust at one day, and it will also become corrosive and then useless. You have to replace this. So specifying the surface roughness is almost as important as selecting the right grade stainless steel. Like if it is a very finished surface where the moisture cannot be stay there at the surface, it will stay longer, or maybe corrosion cannot occur on that. If it is a rough surface, if it is a small, if not smooth, like RA factor is 2.1 micron, RA factor is 0.74 micron. You see this point where the roughness is more, where the moisture content can stay there on the surface. It can discolor and then corrode. Here in this surface is very smooth, 0.74 micron is the surface of the stainless steel. So where no moisture content can be stay there on the surface, so it will be helping in anti like corrosion properties are there, like corrosion resistant properties are there in this. It's one of the project which I was doing it during my tenure in the industry when I was working there. So till today also I am in touch. This is a storage tank facility of IOCL at coastal area. This is huge tankages all over India. So population of the tankage is there, and in all the tankages you find the corrosion somewhere here or there. So they are spending huge amount of money. Even the roof top of the stainless steel roof top 316 gets perforated within 5 years time. 5 years time it is perforated. So this is, you can say, another form of corrosion. It's a leak seepage from the storage tank. It's a severe corrosion at the bottom of the tank. First shell course, see this corrosion. So this is a staircase also is broken down during the service life itself. Within 4 or 5 years, staircase is or the shell gets perforated by the seawater chloride content on that. So right selection of material is most important for the engineer to suggest. It's a corrosion having different level, which I will be covering some other presentation. So low corrosivity C1 indoors, rural area where very low or no pollution, where 3 or 4, it's a type of grades also mentioned there. Moderate kind of corrosivity where rural or urban with low pollution level. So it's also stainless steel, but it's a moderate kind of corrosivity. So it's a 3 or 4 material will be okay for that kind of material. Urban and industrial area where moderate pollution level, but here you have to clean the surface properly. These surfaces are to be cleaned. If you have seen the Delhi Metro also getting cleaned every day. So if they don't clean it, that is also 4301 material, 304 material outer surface. If they don't clean this material, then that corrosion may occur very soon on that surface. So they have to clean every day. This coach of Delhi Metro getting cleaned. So 4301 example, again, it's cleaned regularly. You have to clean it if it is a smooth surface and surface finish the surface roughness value is most important, like RA factor. If RA value is in very smooth or 0.74 or 0.25, instead 0.25, then chances of corrosion are very less. You just clean it and then its life is increased. This high corrosivity area where the seawater offshore applications. So like I show you that applications of also that is a high corrosivity. 4404 is a 316 smooth grade surface finish is used, but that is also getting perforated. Our stainless steel, carbon steel tank with the stainless steel roof, that is also get perforated in 5 years time in the coastal area. That's high corrosivity area. 2205 kind of grade, duplex grade or some other higher grades applications are there for that. So it's a high corrosivity, again is a offshore application where the oil rigs, their oil comes out from the C. So here again the grades are 2507 or 254 SM. Another stainless steel high grade PRE, pitting resistant equal number higher than 42, 43. So that is used there where high corrosivity is there, marine atmosphere and high degree of salt exposure. So summary is this, I'm not giving the solution in this presentation. Solution will be on the presentation. The corrosion form is uniform corrosion, very high pH value or very low. Pitting and crevice corrosion in environment containing chlorides contents. Stress corrosion cracking, tensile stress plus chlorides plus high temperature. Corrosion fatigue is cyclic loads plus aggressive environment. Intergranular corrosion is due to the high carbon steel and heat treatment process is incorrect. And galvanic corrosion dissimilar metal. And atmospheric corrosion is exposure to the atmosphere. So this is a summary. And conclusion is that stainless steel, because this presentation is made only for the stainless steel, is not always stainless. Whether corrosion will occur or not, and the form of corrosion attacks depends on the combination of service environment and the alloy composition. So there are environment which cause permanent breakdown of the passive layer. Under circumstances where passive layer cannot be rebuilt, corrosion occur on the unprotected surface. It is important to know what you expect from the steel. Does it has to be bright or can staining be accepted? So it depends on the demand and expectation. There are tools for making correct material selections. So that tools also can be covered in the next presentation if given a chance. Sir, thank you very much for your attention. In case if you have anything to ask.
Thank you, Kalraji. Session is open for the question answer.
हृदय जी, तो आप शेयर करोगे ना प्रेजेंटेशन?
हाँ, शेयर करूंगा सर।
ठीक है।
शेयर
इसमें जरा दो स्लाइड पहले इस पे जाइए, कंक्लूजन वाले में दोबारा। इसमें जो ये 316 और 316L ग्रेड है, तो L इज बेसिकली ए लो कार्बन और
लो कार्बन सर।
ओके, सो इट विल हैव ए बेटर कोरोजन रेजिस्टेंस।
बेटर कोरोजन रेजिस्टेंट प्रॉपर्टीज होती है सर 316L में भी, और अदरवाइज इट डिपेंड्स ऑन दैट एनवायरनमेंट के ऊपर। हम 316 और 316L में या कोई भी मटेरियल हम ऐसा रिकमेंड नहीं करते हैं। इट डिपेंड्स ऑन दी एप्लीकेशन, आपकी क्या एप्लीकेशन है उसके बाद ही फिर हम रिकमेंड करते हैं।
क्योंकि जैसे फर्टिलाइजर इंडस्ट्री में जहाँ अमोनिया वगैरह से कोरोजन होता है, वहाँ जनरली 316L टाइप का ग्रेड यूज करते हैं।
कौन सी इंडस्ट्री में सर? फर्टिलाइजर इंडस्ट्री में। ओके, 316L यूज तो करते हैं। 316L इज सुपीरियर टू 304 आल्सो। अदरवाइज हाँ, उसके लिए 316L और 304 का भी रिप्लेसमेंट आता है अदर दूसरे स्टील्स में सर, वेयर हाई कोरोसिविटी एंड कॉस्ट इज नॉट इंक्रीज्ड। तो हम उसके ऊपर उस प्रोजेक्ट्स के ऊपर भी काम करते हैं।
तो इन दोनों में क्या मॉली होता है? 316 में
क्रोम निकल मॉली। 3 इसमें एक्चुअली आयरन में, अगर हम स्टेनलेस स्टील का अलग से वो है, अगर हम इसको क्रोम और निकल होता है स्टेनलेस स्टील 304 में।
हाँ जी।
फेरेटिक ग्रेड में सिर्फ क्रोमियम होता है, और 304 में क्रोमियम प्लस निकल है, 316 में क्रोमियम प्लस निकल प्लस मॉली है।
ओके।
हाँ,
तो आप जो अल्टरनेट ग्रेड बोल रहे हैं उसमें क्या कॉपर वगैरह होता है?
नहीं सर, उसमें निकल की एक्चुअली इट्स वेरिएबल। अपनी मार्केट जो है ना, काफी फ्लक्चुएशन होता है इसमें स्टेनलेस स्टील मार्केट में, स्टील मार्केट में नॉर्मली। तो बिकॉज ऑफ निकल कंटेंट, निकल जो है वो अगर बढ़ जाता है तो स्टेनलेस स्टील बढ़ जाता है, निकल कम हो जाता है तो स्टेनलेस स्टील कम हो जाता है। तो ये जो 304 का और 316 का जनरल ग्रेड स्टील है, जो लोगों को सिर्फ यही पता है, तो वो होता है 18.8 is 304 and 18 10 and 2
या
ये होता है 316।
316
तो
करेक्ट।
हाँ, उसमें 8% और 10% दोनों में अलग अलग निकल है, 304 में, और 10% है 316 में। सर ये निकल बढ़ेगा, इट मेक्स अ ह्यूज इम्पैक्ट ऑन दी प्राइसिंग। तो इस निकल को का कोई स्टेनलेस स्टील की पोरोसिटिविटी को कम करने में कोई फैक्टर नहीं है, कोई इंपॉर्टेंस नहीं है इसकी। If the people don't want nickel, we can remove nickel. We can reduce also nickel and the same strength के ऊपर stainless steel recommend कर सकते हैं। Like 316L का pitting resistance equivalent number है 24, मैंने एक स्लाइड में दिखाया था आपको।
या
24 उसका PRE नंबर है, तो हम उसके इक्विवेलेंट जो है ये डुप्लेक्स स्टेनलेस स्टील 2101 रिकमेंड करते हैं। ये लीन डुप्लेक्स है जिसमें 21% क्रोम है, 1% निकल है। क्रोमियम की कॉस्ट ज्यादा नहीं होती और निकल की कॉस्ट ज्यादा होती है। तो इसमें हमारा एट अ पीक टाइम, जब जैसे आज का टाइम है 304 का रेट ज्यादा है हमारा, बहुत हाई है, हैवी रेट है, तो हम वी कैन रिकमेंड डुप्लेक्स स्टेनलेस स्टील इंस्टेड ऑफ 304 which is having better properties, better corrosion resistant properties, and we can reduce the thickness as well because strength भी ज्यादा है उसमें। उसका 240 का स्ट्रेंथ होता है 304 और 316 में, और डुप्लेक्स के अंदर सर 450 MPa का स्ट्रेंथ है।
तो जो ये हाई टेम्परेचर प्लस कोरोजन होता है,
हाँ
जैसे कि फर्नेसेस वगैरह में,
हाँ जी,
तो वहाँ क्या यूज करते हैं?
वहाँ पे सर हाई टेम्परेचर के लिए तो आपका 309 310 के ग्रेड यूज होते हैं। उसके अगेंस्ट में हम अलग दूसरा ग्रेड करते हैं वेयर वी कैन रिड्यूस द थिकनेस। अगर थिकनेस रिड्यूस हो जाता है तो उसमें हमारा वेट भी कम हो जाता है, फिर रेट भी कम लग जाता है, देन ओवरऑल कॉस्ट, प्रोजेक्ट कॉस्ट गेट्स रिड्यूस्ड।
तो जो ये 309 और 310 ग्रेड है, इसमें हाई टेम्परेचर रेजिस्टेंस के लिए क्या एडिशनली ऐड होता है?
सर 310 इसके अंदर मेरे को एक्चुअली आई एम नॉट इनटू, आई विल जस्ट चेक। मैं इसके ऊपर मैं अभी नहीं कमेंट कर पाऊंगा, सॉरी फॉर दैट, बट मैं इसको आई विल क्लियर दैट सर डाउट आल्सो टू यू।
ओके, बट मुझे लगता है उसमें भी निकल ही ज्यादा होगा।
सर निकल तो ज्यादा है ही है उसमें, 310 में और 309 में निकल तो ज्यादा होता ही होता है, बट उसके अलावा जो है टेम्परेचर क्यों विथस्टैंड करता है ज्यादा, इसका मुझे अभी इस वक्त मालूम नहीं है।
ओके,
कलरा जी, ये सेल्फ लुब्रिकेटिंग मटेरियल भी आजकल आते हैं, तो उसके बारे में कुछ आइडिया है क्या आपको? उसमें शायद रस्ट वगैरह नहीं लगता ऐसे मटेरियल में।
सर वो स्टील तो नहीं है, कोई और मटेरियल होगा सर।
जैसे बेरिंग्स है ना, बेरिंग्स,
हाँ
उसमें यूज किया जाता है इस तरह के मटेरियल को।
सर वो तो पॉलिश्ड मटेरियल होता है, जो बेरिंग का मटेरियल है दैट इज पॉलिश्ड मटेरियल विच इज आरए वैल्यू, जैसे मैंने बोला सरफेस रफनेस वैल्यू which is you can say less than 0.25, less than 0.25।
ओके, तो उसमें रस नहीं लगेगा।
डेयरी में विवेक हमारे हैं, वो काम करते हैं, तो उनसे पूछे कि जो जो अल्फा लेवल या कोई भी टाइप का ऑफ ट्यूब है, तो उसमें 0.25 का आरए वैल्यू लेते हैं बिकॉज वेरी वेरी हाई कोरोजन रेजिस्टेंस प्रॉपर्टीज देयर इन दैट।
ओके,
रेफरेंस वैल्यू इज 0.25, लेस देन 0.25।
कालरा जी, आई कैन ऐड समथिंग टू दैट। टिपिकली इसमें इस तरह के मटेरियल होते हैं सेल्फ लुब्रिकेटिंग बेरिंग्स में, जिसमें कि देयर इज ए मैट्रिक्स एंड दैट मैट्रिक्स कंटेन्स लुब्रिकेटिंग मटेरियल्स। तो उसमें क्या होता है कि वो उसमें ग्रीस की जगह, बेरिंग में जो ग्रीस आपने डाली हुई है और उसके दोनों तरफ सील्स लगाई हुई है, उसके बीच में वो ग्रीस डालने के बजाय वो ऐसे मटेरियल की मैट्रिक्स हो जाती है कि जिसमें जैसे बेरिंग रोटेट होता है तो इट रिलीजेस द लुब्रिकेशन मटेरियल।
ओके,
एंड इट हैज ए डेफिनेट शेल्फ लाइफ, डेफिनेट यूसेज लाइफ।
आई सी।
उसमें क्या होता है कि टेक्सटाइल इंडस्ट्री में या आपकी फूड एंड फार्मा इंडस्ट्री में, जहाँ पे यू हैव ए सिग्निफिकेंट प्रॉब्लम ऑफ लीकेज, अगर आपकी ग्रीस या ऑयल लीक होती है तो वहाँ पे इट इज नॉट, प्रोडक्ट में मिक्सिंग अलाउड नहीं है, और इन टेक्सटाइल और पेपर इंडस्ट्री इट कैन डिसकलर दी प्रोडक्ट। आपके पेपर के ऊपर ग्रीस गिरेगी या टेक्सटाइल पे गिरेगी तो उसके ऊपर मार्क आ जाएगा। तो उस तरह के केसेस में वो ये यूज करते हैं, लेकिन इसकी लिमिटेशन ये है कि वो जैसे 6 महीने में, 1 साल में या 2 साल में, whenever they have a major maintenance cycle, they straight away replace those bearings because they cannot be re-lubricated.
I see. Okay.
So
Kalra साहब, just for your आपकी बात का एक्सटेंशन बोलता हूँ, 316L is majorly used in the hygienic industry, let's say dairies, beverages. So like you rightly said, the surface finish is very important for two reasons. One is that when you have a good surface finish, it is less prone to corrosion. And second thing, after every batch of production, it needs to be cleaned. So a good surface finish, ensures a better cleanliness, so that the next batch, when it is produced, there is no contamination in that from the previous batch.
Yes. Right.
Hridesh, one question I have. You were saying about nickel, and nickel is what is expensive. So why do we use nickel then if its role play is not as important?
People are not aware about this. So we actually, wherever I'm working, or I worked for the previous company for 10 years. So in that, nickel actually doesn't play any important role for the corrosion resistant properties. But the food and dairy, they ask for the nickel also. So, but we have an easy replacement, where we have a very easy like other products also, which can give the equal life if without nickel as well. Like we have a replacement of 304 in the market without nickel as well, but that becomes a ferritic grade. Ferritic grades, like you can वो चुंबक बन जाता है सर, वो means it becomes a लोहा. So people are having a mentality in the mind. So it's ये तो लोहा है. Chromium is only chromium there in this. It's a no nickel. It means it's a loha. So it's not that. Corrosion properties, stainless properties जो आती हैं वो chromium से आती हैं. The higher the chromium, the higher the corrosion resistant properties there in this. Higher the corrosion. तो corrosion जो है वो होना चाहिए nitrogen है, moly है. These are the three factors which give the properties. So I know the material which is equivalent to 304, better placed cost wise without nickel, better placed than 3016, the cost wise also equivalent to that without nickel. But that will become a ferritic grade. So people don't accept sometimes ferritic grade. If you talk about food and dairy, they will never touch this grade. Or some other pharmaceutical companies also, without nickel they don't touch. But in the automotive grade, automotive industry, they are only going for the ferritic grades. Ferritic grade application like 403 grade or 1.45, 12 यानी 409 लेते हैं. अभी for जो अभी नया ये निकलता है जो भारत 6 है, तो उसमें they will go for high temperature application. High temperature application के अंदर सर उसमें उनके नए ग्रेड है, दैट इज ऑल्सो फेरेटिक ग्रेड 439, 444. सो ये ग्रेड जो है विदाउट निकल है सब, देर ऑल फेरेटिक ग्रेड्स. सो बट corrosion resistant प्रॉपर्टीज में इसमें कोई फर्क नहीं है फॉर ऑटोमोटिव, फॉर एग्जॉस्ट एंड ऑल, फॉर ये एप्लीकेशन में यूज होते हैं
for the mufflers and exhaust systems.
Yes sir.
Those applications. But that means that there is a psychological thing that if it becomes if the SS becomes ferromagnetic, that means it is prone towards attracting the magnets. Is it that magnetic properties are
it attracts magnetic. If nickel is not there, then it attracts magnets. Duplex stainless steel, like you see in this slide 2101, these all are magnetic grades. Ferritic, it's magnetic, not ferritic, but it's magnetic. It's a microstructure is 50% ferritic plus 50% austenitic. Okay. So it attracts magnets as well. So people says it's a loha है, ये तो नहीं use कर सकते हम लोग.
Correct. But it's psychological then.
Yes.
Okay. Thank you. Thank you from my side.
Yes.
I am having one question. Hello.
Yes sir.
I am having one question, and the question is that, as you said that in the environment there are many particles, or we can say elements, which leads to corrosion. Can you give us some examples by which we may know that the particles present in the environment, which type of particles will lead to corrosion?
So first of all, it depends on the environment also. Like if it's open, if you go to Delhi bus stand of stainless steel bus stands, in the environment there are water as well as air. So if it is mixed with moisture and the air, it reacts with this material, and discoloration comes from the bottom, from the soil part, and then it converts into the corrosion. So it's all depends on if he gets moisture or if it gets the air. So it will lead to the corrosion. It's in the atmosphere everywhere. So if it is indoor activities, if it is indoor there, so railing, you can use non-magnetic material or magnetic material as well, finished material. If that rolling puts outside the here in Delhi, it will not or maybe least affect that railing or something. But if it goes to Bombay area, coastal area, it can attract the discoloration or particle where the chloride contents are also there in the area. So it depends on the area environment also. Dry atmosphere, there is least corrosion active there in this in the atmosphere. If it is a coastal area, the moisture as well as air, it leads to the corrosion.
And one more question is, sir, when we add chromium, so how chromium helps in preventing the corrosion?
Sir, इतना डिटेल तो chromium is a fact. Actually, the corrosion resistant property is there in the chromium and moly and nitrogen. So, but that how it prevents that, I I have to be metallurgist. I don't know, sir, on this question.
Any more questions from participant side? So if there is no question, then I am thankful to Hridesh Kalra ji for being with us and giving his valuable time. Thank you, sir.
Thank you, sir. Thank you, everyone, sir. Thank you, everyone.
Thank you, Kalra ji.
Thank you, Kalra ji.
Nikhil
Thank
ji,
you,
thank you,
Kalra
Kalra
ji,
ji.
for a very nice presentation.
Thank you,
sir. Thank you so much.
Thank you, sir, for nice presentation.
डॉक्टर निखिल, मैं आपको प्रेजेंट
सर इसको हम ऑनलाइन कर दें, कोई दिक्कत तो नहीं है? क्योंकि कुछ लोग जैसे स्टूडेंट्स हैं वो बाद में भी देखते हैं।
नहीं, पीडीएफ में कर देता हूँ मैं इसको कन्वर्ट, देन आई विल सेंड इट टू यू।
ओके सर, ठीक है जी।
ठीक है सर,
कन्वर्ट इसमें हो जाएगा सर, ऑटोमेटिक हो जाएगा।
अच्छा,
हाँ जी,
ठीक है सर।
तो मैं आपको भी लिंक भेज दूंगा। थैंक यू सर, मैं अभी से लिंक करता हूँ। ओके, थैंक यू।
हाँ जी, हाँ जी।